I'm Shivani Patel. I'm a program manager at Microsoft in Azure Machine Learning.
I'm Jordan Edwards. I'm also a program manager at Microsoft working on Azure Machine Learning.
Yep. And so today we're going to talk about MLOps and basically accelerating your data science workflows with DevOps. All right. So for today, we're going to be covering what is MLOps, what does MLOps lifecycle look like, and how do customers in the real world use MLOps and get to an MLOps workflow. Raise of hands, how many of you guys have heard of MLOps, used MLOps, familiar with it? Okay, well,
a little bit. A little bit, like 10% of the room.
All right, so some of this might be repeat for some of you, but let's kind of dive in a little bit into the ML piece of it. So what does the machine learning lifecycle generally look like? So first you kind of start with getting this data acquisition, cleaning it up, putting it into a data set, and then developing, experimenting, and training, and eventually coming to a model that is solving a real business problem. Then you package it up into a format where you can actually run it and get value out of it. And then next you want to go ahead and validate it, making sure that it's reaching all accuracy, performance thresholds, any sort of regulatory compliance that you have in place for that model. Next is the fun part of actually deploying it and making predictions. So actually getting the real value out of your model. And then the last phase here is monitoring it. So you want to make sure that you're constantly looking at the model, making sure that it is going to perform and give you the value that you expect it to. And then once it's deprecating and not performing as well, kicking off this training pipeline all over again. So that's pretty much the machine learning lifecycle in a nutshell. Now, what is MLOps? So that's basically just bringing DevOps principles to your machine learning workflow. So that's integrating a continuous integration kind of flow into the data science workflow. So it's automating the building and testing of your code, so creating these repeatable training pipelines, and then providing this continuous deployment workflow, which is automating the validation of the package model and then deploying it out into your target device, server, wherever you're deploying your model to, and then monitoring not only your pipelines, your infrastructure, the model performance, as well as the new data that's actually coming in and creating this data feedback flow to kick off this pipeline all over again.
Sweet.
Okay, so how is this different from DevOps?
So how many of you have heard of DevOps? Okay.
Just making sure we're at the right conference. So as you can see, you bring in data and models into your system and it pretty much just implodes it. So you have this small integration tiny unit test. You're kind of not managing a lot of pieces in a traditional software development lifecycle. And then when you move into an ML-based lifecycle, you have data tests, model tests, your system level monitoring, your model monitoring, the training pipeline monitoring. So it gets a little complex.
A little bit, yeah.
Yeah, so what ends up happening is that your ML code is actually such a small piece of your infrastructure. You have so many more assets that you have to manage in a scaled out machine learning workflow. So essentially what makes it really different is you're putting together 3 different workflows here. You have your data engineer that is cleaning up this data, creating these data pipelines, your data science workflow, which is experimenting, creating the model, and then your software engineer who's operationalizing the model. So what makes it so different is that the versioning of your assets ends up being very different. You need to be able to version the data sets, the schema, how it's changing. Along with that, you also need to have that lineage of where your model is coming from, where it's being deployed, what data sets are being used in your model. So you end up having a billion more requirements on additional artifacts that you're creating.
Yeah.
And then the second piece here is model reuse. It's very different than reusing software. So you need to create a training pipeline where you're caching a bunch of these steps that you're creating, so then you can maybe transfer learn, fine tune the model that you've created so it stays relevant in that context. So inevitably models tend to decay over time. Everything in the world is changing around us, data is changing, so you have to go in and update these models over time. Now what does the lifecycle look like? So initially, what ends up happening is you start by doing kind of this exploratory phase of first getting in that data, creating a model, finding an algorithm that works, and then you have this really useful model. So your data engineer is hoping, okay, maybe this data acquisition, hopefully this works when I actually scale it out. Data scientists create the model, and then you have your software engineer, your DevOps engineer, who's saying, how the heck do I deploy this out? Where do I deploy it? How do I package it?
Tends to be a lot of friction between the personas here, yeah.
And then the next phase here is actually reproducing that process of actually creating your model. So this is where the continuous integration piece comes in, turning your training process and your training pipeline into this frozen, pipeline that you can reproduce over and over again from wherever.
So for those here who aren't familiar with data science and data scientists, how do they normally work today?
So right now what happens is you're data science, you're working on your own laptop, so you're training in your own environment, you're tracking your own things. So there's no standardized approach to creating your model. You're doing it in your own context, which is really hard to share across a huge team.
Yeah, a lot of them are researchers or have PhDs. They're not classically trained software engineers, and thus they don't understand things like version control. So taking any of the work they do and bringing it to production is tricky.
Exactly. So you need to be able to capture all these pieces that we talked about, data sets, the environment that you're actually working in, the code that you're creating, and then all the metrics that come along with creating that model. So now we have, all right, the next phase is let's just get this model running somewhere so you're actually getting value from there. So once you push this model into this centralized store, forcing the data scientists to kind of standardize a little bit of their approach and push what they've created into a central store, you kick off this training process of actually packaging up the model in the context of its deployment environment. So your training environment, your deployment environment may be different. So making sure you have that environment and then testing it, throwing it with some sample input data, making sure it's behaving the way that you expect it in the packaged format. And then releasing the model. So this is triggering it and pushing it out into a device, a server, wherever your deployment target is. So that's where your ML engineer comes in. Now, the last phase here is actually automating it and reaching that happy state of MLOps. So this is basically, we start with the data engineer that has a centralized data store. They create these pipelines that's constantly pushing in cleaned up data into a centralized data catalog, and that's where your data scientists can pick up the new data, trigger this pipeline that essentially will go through these standardized steps of creating a model and then compare it to the last known model that was out there, the last known good model, and then pushing this new model that's been certified by the data scientists into the centralized model registry. And that's where your ML engineer, software engineer comes in, picks it up, triggers a deployment pipeline that'll go through kind of the same steps as it did before, package it, certify it, so you have a standardized way of testing the model. So you're deploying your model out with confidence. And then maybe doing some A/B testing, which is testing different versions of the model, and then monitoring that feedback and the outputs that are coming out of the different versions of the model.
So how do I do A/B testing with machine learning models?
So basically with A/B testing is that you'll have a kind of scoring endpoint, or basically the way that you call the model, and you'll have a bunch of different versions of the model behind that same scoring endpoint. So when you call it, you'll configure the traffic of data going to each of those versions, so then you can ramp up and down according to the performance of those models.
So the model behaves like any other microservice. Okay, cool.
Exactly. And then you want to bring in that data that you're getting, pushing it back into your central data store, so then you have fresh, new, current data that you can train your models on.
Can you describe what the data analysis services are?
Yes. So basically what happens is your models that are out in production, the data that's coming into the model can be changing over time. So that'll pretty much change the performance of the model because it's getting these unexpected inputs. So being able to monitor those pieces and understand the performance degrading immediately and being able to kick off these retraining pipelines as you see the model performance decaying over time with the new data.
So say you've got a model running on an offshore oil rig, detecting if there's a valve or a compressor is about to blow. Temperature goes from spring to summer. It's now much hotter. The sensor values are higher. You're going to get a lot of false positives on there's an incident. So those types of signals are what looking at drift on the model is all about.
Yeah. You want to make sure it's, again, staying relevant in that context as time and the world changes around us.
Yeah. All right. Cool. So I'm just going to talk about sort of how Microsoft at a macro level tries to address the issues in the MLOps space, and then run through a few different customer examples to give you a flavor for what MLOps looks like in the wild. So Shivani touched on sort of the key problems of MLOps. How do you reproduce models when data scientists are largely researchers coding on their laptops? How do you reproduce predictions? So say a bank is running a model which is determining if they're going to approve or deny a person a loan, they need to be able to demonstrate exactly why the model gave that prediction for approved or rejected. So you need to be able to trace back exactly which data, which features were used to train this model in the first place, and prove that things like fairness testing, bias testing were done, especially when you're dealing with these highly regulated industries. Then when it comes to operationalization and automation of the ML lifecycle, again, that's about more than just the data scientist or the software engineer or the data engineer in isolation. It's about how do all three of them work together in a collaborative fashion. Oftentimes the data you have when the data scientist trains a model isn't available when you're trying to make predictions. So how do you ensure you can have that same data, quality of data, availability of the data, and also that the model is performant? So you're trying to have a real-time system detecting if there's a giant spill on a factory floor, that model can't take like 10, 15 minutes to run in a real-time context. So how do you operationalize, automate three different personas, oftentimes different tools and technologies together? And the answer is hopefully with DevOps. Then there's also how do you do collaboration within and across teams on your ML workflow. So as Shivani mentioned earlier, you can't share models around like you can share normal software packages. You need to actually share a pipeline along with the model that can be used to reproduce it and tune it based on the data specific to that scenario. So one example is, say I have a model that's detecting anomalies in video feeds, like the workplace safety one I mentioned earlier. That model might be trained for a factory in Beijing, but if you want to use that same model for a factory in, say, the US, you need to customize and tune that model based on footage of what the video feeds in that factory in the US are going to look like. Then there's how do you collaborate and share. Another thing we've seen is really common with large enterprises in particular is each of their organizations have independent data science teams running projects and experiments right now. And lots of them are working on very similar workflows, like so 80–90% the same. So how do you collaborate and share on, hey, I'm using these data sets to train these types of models and solve these types of problems? Then when it comes to enterprise readiness, I mentioned briefly highly regulated industries, areas around how do you do governance when dealing with data and machine learning, especially when you're talking about deep learning and models that are really hard to understand because they're so convoluted and deep that even people with PhDs don't know what they're doing. And then how do you do compliance and infrastructure as code when you start to deal with specialized types of hardware? The cost management comes into play if you're using compute with large amounts of GPU, large amounts of memory, jobs that take a really long time to run. It's not like a normal software build where it takes a few minutes. Some of these jobs can take days or even weeks to run potentially to get a good model. So how do you trust that? So from a Microsoft and Azure point of view, we sort of have this recommended flow, which involves using these three different technologies together. Data Factory, machine learning, and DevOps services each have pipelines that are optimized for the different personas that are involved in this flow. So you have your Data Factory for your data engineers, Azure Machine Learning for your data scientists, and DevOps for your DevOps professionals. And those are just sort of the three personas, hopefully working happily together to get the end-to-end flow going. So as far as what does, sure, an Azure platform, but any platform need to be able to effectively manage MLOps flows, there's keeping track of your infrastructure, your code, your data sets. Data versioning is super important, being able to, you can't dump all your data in a Git repository, turns out, and you can't really diff large binaries in Git. So you need ways to track metadata, profile, hash, and compare changes in your data over time to determine, has my data changed enough to warrant training a new model? Has my data changed too much to the point where now my training pipeline is going to be useless because half the columnized features are dropped out of the tabular data? Tracking your environments. So say I train a model on my laptop, I want to know the exact state of the world when I trained it there. What were all the Python packages? Was I using Docker? If so, what Docker image was I running? And how do you easily shift that from the training to deployment side of the house? Tracking all my runs and experiments. Another common thing we'll see from enterprises is, hey, this data scientist left my team. I have no idea what they did. All their work is gone. because it was just sitting on a Jupyter notebook on the laptop. So having an easy way to track your runs in the cloud should not impede the agility of your data scientist, but should give you a way to centrally track and understand the work that's going on and the types of experiments that are being run, the types of models that are being produced. And then, of course, the models themselves, it's important to be able to share and reuse those and to integrate those models and events around those models into your end-to-end ML-infused application lifecycle. Then when it comes to making models less of a black box, you need ways to explain how models are behaving. So we have a few different approaches that we try inside of Microsoft, mostly using these open source explainers called like SHAP and Lime. And what they will do is actually analyze for a given machine learning model all the features and relative importance of those features into your model that's making a prediction. It's super useful, again, if you're talking about any highly regulated industry, whether it's financial services or healthcare. Profiling the model, determining how long the model takes to actually go and run, and then deploying it to a variety of contexts, whether that's as a real-time API, to an edge device, or as part of a larger data pipeline. Most customers we've seen right now are mostly working on getting their models integrated into data pipelines in batch and running them in more of an offline fashion to help build trust around the model, with an eventual goal of getting those models running in real time on the edge, closer to the devices, and making predictions faster and adding more business value. And then for enterprise lifecycle management, there's data pipelines, your training pipelines, release pipelines, and then eventing to connect everything together end to end. So as far as we have documented best practices around how to do this, and there's actually a repository on GitHub you can go and look at that's got this whole flow set up, including ARM templates to go and deploy everything on Azure. But basically you have your data engineers working in tools they're comfortable with, dropping data into whether it's a blob storage or a SQL database. You have your data scientists who are working, checking code into Git, built-in experiment tracking. On top of that, when they're ready to say, hey, I think this model is good, all they do is submit a pull request to the master branch of the Git repository that will actually run code quality checks, data checks, unit tests, and build and publish the reproducible training pipeline that's then shared along with the model. And then from the model registry, you tie into your DevOps release pipeline, whether that's Azure DevOps or anything else. Again, doesn't really matter. The whole goal is to show how this flow can work end to end, and can go from, I have a data scientist doing something in a notebook locally, to now the code's checked in, there's a reusable training pipeline published, there's an official model, and I have the full end-to-end lineage to figure out where everything came from in that flow. And again, that GitHub repo at the bottom shows how you can actually go and do it. Again, just another pivot on the same thing, which is to bring ML workflows to production, you need scalable compute and storage to train your models, the ability to manage all the assets, collaborate and share on them, package and validate your workflows before bringing them out, deploy and serve them at scale. Our general rec from a Microsoft point of view is to use containers whenever you can. Easy to encapsulate all your dependencies, easy to build it once, run it anywhere, whether it's in the cloud on a Kubernetes cluster or running on that offshore oil rig I mentioned earlier, and then monitor the models when they're deployed and know, as Shivani mentioned, like when you should go and retrain them. Just a few customer stories about how our customers actually doing MLOps. So this is a transportation company in Canada, and they're using 16,000 models at scale, one model for each of the bus stations to determine bus departure times more accurately. They're called Translink, you can go look them up. But basically, they use DevOps and Azure Machine Learning together to submit a request to pull all the data in, train the model, and do the scoring in batch. And based on the results of that, they'll tune their calculations around estimated delays and how long it's going to take for the buses to arrive or depart. Just an example of for more of your classical government industries, how you can just take a pipeline, train it for one bus station, and then scale it out to, again, 16,000. So it's how do you take that flow and bring it up and out and really help to do production ML. We've seen the same thing with customers who will train a model for one retail store, then take that same training pipeline, apply it against all their data for all their stores in the country or around the world. Again, this is how you get that value. So another customer here in the retail sector using MLOps to ship recommender systems. So in this case, again, they use Azure Machine Learning and DevOps together to customize, train, and publish models. And in this case, they actually deploy the model as a real-time API on Kubernetes. And they also use the model inside of a Spark pipeline to generate these sort of static recommendations on products, which they push into Cosmos DB. And then those are both served from whether it's the website, the mobile app, whatever. But the whole point is it's the combination of the machine learning services and DevOps services that allow them to actually do this at production scale. And of course, it's mostly because I ran out of space, but the data engineer is an important part of that, making sure the Spark pipelines are working properly, making sure that all that data in the bottom and side of the data lake is available and clean. So all super important roles. And then another example here is for MLOps for running predictive maintenance at the edge. So again, take machine learning, DevOps together. In this case, they have the maintenance models that are deployed and running on IoT edge devices, taking all the sensor data info as it comes in, determining if they want to send an operator to the offshore oil rig to go and take a look and see what's going on. And that same feedback collection process goes in. Like the operator can say, like, oh, that was a good prediction or a bad prediction. Those signals are fed back in to help improve the model over time. And I'll let Shivani recap and close it out.
A little quick recap. So,
Yeah.
I mean, the key takeaway here is that it's not just using a bunch of technologies together. It's bringing this workflow of 3 different personas to collaborate together and scale out. So essentially, it's a lifestyle that we want to introduce with MLOps. So it's not impeding on certain workflows, but bringing all these workflows together to collaborate and push their data and artifacts and what they're creating into centralized stores that other personas can go in and pick up.
Yeah, and again, if you're looking into, for your organizations, how to do digital transformation, how to bring IT into the fold for data science, the recommendation is to not try to force a ton of existing software engineering practices onto them. Instead, give them tools to make it easier for them to get compute in the cloud, make it seamless for them to track their work, and make it more apparent to them the fact that they're training these models, someone's actually going to go and use them. Because one of the most important pieces that we bring up when talking to customers is 88% of models that are trained in the enterprise never actually make it to production. So unless you put these MLOps processes into place, your organizations are just never going to get there, really. Cool. And yeah, that's all our content. So thank you.